Namaste friends, welcome to this channel Dr.ARM's Chemistry. We were discussing synthetic methods of organometallic compounds. So in that case we have seen so many types of methods, and the next method is from the same type, and this is synthesis of metal alkene compounds. Means here we are going to see the method on the basis of the nature of alkyl or allyl group, which is introduced to the metal organometallic compounds, or which is present or attached to the organic component of these reactants. So synthesis of this is 14th. Synthesis of metal alkene complexes. Metal alkene complexes. So here we are expecting that there is a bonding between metal and a double bond. Metal and a double bond. So there is some additional structure present to this. So it depends upon the nature. So synthesis of, here we will see the acyclic and cyclic alkene complexes. So first of all, we will see the acyclic complexes. If you take the example of Cp2CO, when it is reacted with potassium and C2H4, it gives Cp2, Cp, CO, and this C2H4. CpCO, C2H4 twice. Now this CpK or KCP. Another example is here we will find that there is bonding between this metal and this alkene components. Now another example is CpCO plus COD. Here COD means cyclooctadiene. Here COD is cyclooctadiene. So it gives CpCO COD plus twice CO. Third reaction is RHCl3 plus 4 C2H4 gives. So these are the C2H4 representations. So this is one C2H4. This is linked to RH rhodium. Another, this representation of second molecule of C2H4. Then The cells are bridging ligands. So this is third CH4 and this is fourth CH. Reaction gives us a PCO5 plus there is only one, not four, only one. So when it is heated at 135 degrees centigrade, and treated with Na3O NO minus CO2, then it gives this PCO3. So these four carbons are simultaneously providing the pi electrons for bonding with iron. Is Cp Mn CO3 plus CHO after irradiation Hu minus CO gives Cp Mn CO CO CHO. So this CH2 CHO is bonded here with pi electrons. Next reaction is NiCl2 plus Al Me3 plus thrice so this CH2CH CH2 three molecules are required, so it gives us bonding is like this. So the three molecules are forming this structure. Now after treatment with cyclopterine, gives a stable structure like this. So we get this stable structure. Source of E0 oxidation state. So this bonding of nickel with alkene is used as a tool to obtain the stable source of nickel. So after synthesis of organometallic complexes with metal alkene bond, now we will see the synthesis of organometallic compounds with metal alkyne bond. Synthesis of metal alkynes. Metal alkynes can have various types of bonding modes. The bonding modes are like this. So this is our alkyne, and it can have the bonding with metal like this. So the pi electron bond, here pi electron of this triple bond C bond is used to form a coordinate bond with metal. Or there is alternative way to form this bonding in this way. So this is alternative structure. So here the two carbons atoms are used as the coordinating points, but the number of electrons involved in this bonding are only 2, that is 5 electrons. Then another mode of bonding is like this, R. like this. So it is having a dinuclear structure like this, and two nuclei, that is metals are bonded. So the points of attachment to this C triple bond C is metal to this carbon, metal to this carbon. Then another way is like this. So here we are finding that there is this square planar structure, but here the structure is different. It is like this, metal to metal bond. This is metal to metal bond, and like this. Now another mode of bonding is like this. So we can have these two ways. Like this. And the two pi bonds are showing two carbon metal bonds. Two pi bonds are used to form two carbon metal bonds like this. The pi bond is actually here used as a, this pi electrons are used here as a coordinating points. This donor points of electrons. The first example is CO2 CO8 plus here are its hydrogen, pH, methyl, phenyl, CF3 and COONE. So during reaction the two carbon monoxides are eliminated and we can obtain this structure like this. Metal means here CO. So this is this type of mode of bonding we have seen just now. Next reaction is CP2Ni2 mu CO bridging carbon monoxides plus pH this can be written shortly as pH2C2. So it shows 2 minus, and we can have this pH metal means here nickel, and there is Cp, so here we have obtained another structure, which the type of this structure is also we have seen in the general modes of formation. Next example is Na2 50Cl4 plus, we can show this plus tertiary butyl twice C2, or we can show like this also, tertiary butyl. So the solvent ethyl, ETH, ethanol plus 4NaPH is C6H4NH2. Then we get this, we can say here R, or in order to simplify, we are showing this RNH2, then PT, and the Cls are like this. Tertiary butyl compounds. Now here, this bond angle is 165 degrees here, and the bond distance is 1.24. This bond distance is 1.24 angstrom. So here the pi electron is used as a lone pair for bonding with this mate. Then next is Cp2 Ti CO2. So when it is treated with pH2C2, means pH C triple bond C pH. So it gives Cp then CO, then this triple bond C, electrons here are used for the bonds like this. Here the bond distance is 1.28 angstrom. Angstrom. The next example is triphenyl phosphine to platinum PP C2H4. So after reaction with this PH2C2, it gives triphenyl phosphate P, platinum triphenyl phosphine. Now there is also here formation of this bond angle, it is 140. The bond distance is 1.32 angstrom. So here you will find that there is change in this bond distance and bond angle also. So these examples of alkynes which we have seen now shows the stable complexes. So the coordination between metal and this pi bond, that is triple bond, carbon-carbon triple bond, gives stable complexes. But this is not possible with the benzene. Benzene gives unstable complexes. So benzene does not form stable product. Benzene is like this. So this is benzene. This cannot give me this formation of metal, this pi electrons bonding with metal. So this does not give a stable product. So it is difficult to isolate the metal benzene complexes. The unstable cyclic alkynes can be stabilized by coordinating with metal. So we will give the example like this. So Br. So this is, we are using this, the brominated group. So it gives platinum, PPH3 thrice. So after reduction with NaHg, not Mg, NaHgY, the pH3 group is remove one pH3. pH3 is removed and we get this stable product like this. We can have the structure. So the dimensions like this. The bond is 1.29 angstrom and this angle is 127. 127 degrees bond angle. In this way, the benzene is stabilized by coordinating with metals. Now the next example is so if you take the substituted cyclopentadiene, Me, this is amine methyl groups and it is attached with this benzene. Like this. So when this is heated at 120 degrees centigrade, this methyl group and this hydrogen is removed as CH4, that is minus CH. So as a result we get this substituted product. Me, and this is like this. So the bond and this distance is 1.41. Angstrom. This is also same 1.41 angstroms. This distance is 1.36. This is 1.36, but this is more 1.46, and this is 1.37 angstrom. So in this way, we get this stabilized product. Then next reaction is PgCl2 plus 4 pH C triple bond pH. So this reaction gives these four pH2C2 are given to square planar structures. So pH, pH, palladium. So there is Cl here, Cl, Cl, Pd, Pd. One more Cl is here, and this type of structure is obtained. Now the third reaction is Cp2 TiCl4 plus Mg plus general representation of this alkyne R prime C triple bond C R T R1 R2. So after heating at 20 degrees centigrade in THF, it gives Cp2 twice Cp means Cp, Ti, Cp, and this R1, R2. So this MgCl2. Then third example is this Cp, TiCp, pH plus one more molecule of this pH C triple bond CpH, and the result it gives Cp, Ti, Cp. So after this pH is pH to C2 is that these two carbons and these two carbons are bonded together, giving a 5-membered ring structure like this. So we can have this 5-membered ring structure like this. pH So this is called the metallocyclopentadiene. Metallocyclopentadiene, and this is a stable structure. This is diphenylacetylene complex. It is metallocyclopropene. So it gives stable product in this. If we take the zirconium complexes like this Cp2Zr, Cl2, Cp2Zr, Cl2. So if it is treated with two equivalents of N tertiary butyl, N butyl lithium, when it is treated with two equivalents with twice N butyl lithium, it gives Cp2Zr. So this lithium and chlorines are removed here, and we get this tertiary butyls. Okay, means N butyl twice. Now, if it is when in one way, if it is treated with this pH to C2, then it gives one type of product, that is CpZr. Cp, and these two means C triple bond C is bonded here in this pH. This is when heated with HCl. It gives the products like this: pH, CH2 pH plus Cp2 Zr Cl2. So this is one way of giving these products. When this is treated with pH C triple bond C pH, it gives alternatingly another product, which is CpZr Cp, and here we get pH and this type of product, that is called metallocyclobutadiene. Metallocyclobutadiene. So this when treated with I2, it gives pH I plus there is formation of Cp2Zr I2. So this Cp2Zr is twice in two ways gives different products. So when it is treated with HCl, it gives two, means the complex is broken down and it is converted into this pH CH2 pH, and this Cp2Zr Cl2 is retained. But if it is treated in this way, means if it gives this metallocyclobutadiene, and after treatment with iodine, the CPs are Cp2Zr, these bonds are broken here. Zr C bonds bonds are broken by this iodine, and we get this iodized product. Now this first and most well-known example of cobalt-based metallocycle was prepared by Yamazaki in 1967 by the following reaction. This is well-known example of cobalt-based metallocycle. This CP, this cyclopentadiene, so we generally represent it like this: CP, CO, PPH3, P, PH3, P, PH3. And it is treated with two equivalents of pH, C triple bond, CPH. At room temperature gives the important precursor CP. This is cyclopentadiene. CO. This is P, PH3. And these, here we get this PH3, pH, this is pH, not PH3, pH, and this is also pH. So this product is a good precursor for the host aromatic molecules, and specifically or especially substituted pyridines and similar heterocyclic compounds can be prepared using this product. So this is one of the important type of precursor available here. Using these groups, so this is important precursor for the synthesis of aromatic molecules host as well as substituted pyridines and similar heterocyclic compounds. So thank you very much for watching this video. Please do subscribe this channel and also press the like button.